Hey everybody, welcome here to another quick chemistry video, hopefully a quick one. We're just going to talk about limiting reagents. Now, sometimes these are called limiting reactants. I think we're just going to call this an intro to it. And let's talk a little bit about limiting reagents. And again, sometimes called limiting reactants. A reminder that when we look at a chemical equation, on the left-hand side there, the arrow, there are our reactants, our starting materials, which is why this is sometimes called limiting reactants. And on the product side, or the right-hand side of the arrow, is where we have our products, which is what is produced as a result of this reaction. So what is the deal with limiting reagents? Well, the idea here is quite a simple idea. When these reactants react together in this chemical reaction, wow, I feel like I said reactants and reaction a lot there in that sentence. But when they do react, they will not react sort of equally based on their stoichiometry. And again, that's their coefficients, mole-to-mole relationships. And they will not get used up at the same time. There will always be a reactant that gets used up first. And for our argument here, we're going to use A as that one. And that is what's known as the limiting reagent. And that is the one that gets used up first in the reaction. Now, there's always also a reactant that you have plenty of, and we'll go with B in this case, and that is our excess reagent. And our excess reagent is the reagent that you'll have plenty of when it's all said and done. And you'll actually have some left over, actually, in these reactions. So you have plenty of that excess reagent. You have a limiting amount of the limiting reagent. Now, why is this important? Well, let's just think about this very, very simple reaction here that we're looking at. Now, in order to make our product, which is on the right-hand side of our arrow, we need an A and a B, basically to come together to produce our product. Now, if we go by what we've been talking about here, that A is our limiting reagent, that means at some point when this reaction is taking place, frankly, we're going to use up all of our A. So we'll just sound effect there, cross out, eliminate. Frankly, it is now gone, our A in our example, because it's our limiting reagent. I'll just call it LR here. Now, the excess reagent we have plenty of, so we will still have in this reaction some of the B present. Now, why is that really, really important? Well, if we look at our product here, the only way to produce that product is you need an A, and frankly, you need a B to make A and B coming together. At this point, we no longer have A, which means there is no possible way for you to produce any more products. So you cannot produce any more products at this because you have ran out of our friend over here on the left, A. And the importance of that is whenever you have a limiting reagent situation, it is always the limiting reagent that determines how much product you will produce. And that's what makes this type of stoichiometry problem a different type of stoichiometry problem than just a basic stoichiometry problem, because you have to actually figure out which one's the limiting reagent. Then you have to actually do your stoichiometry problem based on the limiting reagent only. And it does have to be based on some type of calculation, which we'll talk about in a subsequent video here, to determine which one's the limiting reagent. But how do you know it is a limiting reagent type problem versus just a basic stoichiometry problem? The key is this: when you look at the problem and the information given to you in the problem, a very simple way to determine, hey, this is a limiting reagent type situation, and I need to kind of do that calculation, I need to figure out that calculation, is when you look at the information given to you and you look at the both reactants, could have more than two, but in most cases you'll be dealing with two reactants. And if you look at both reactants and information given to you, and you can, from the information given to you, calculate the moles of each reactant, that is your key to know that you need to do a limiting reagent problem. If you cannot get the moles directly from the information given to you in the problem of each reactant present, then it is a basic stoichiometry problem. But if you can get the moles of each reactant, regardless of what information is given to you, maybe you're given grams of each and you could use the molar mass to get the moles. Maybe you have the volume and the molarity and you could get the moles from that. You know, there's a lot of ways you could do that. You could even have some gas information and use a little PV equals nRT and can kind of get the moles of things. It could be actually a combination of each of those. Maybe you got grams of one and some molarity and volume of another. But the key is from the information, I could get moles of this guy. I could get moles of this guy. I know right off the bat, limiting reagent problem. I need to do some type of calculation to figure it out. How do you do those calculations? There's multiple ways to do those calculations. In subsequent videos, keep on a lookout for them. I'll show you probably 3 different ways that you could do it. And I'll tell you maybe which way is a better way than others. But this is a quick introduction to limiting reagent problems. If you have a limiting reagent situation, you got to calculate which one's a limiting reagent. It is not always the smallest amount of moles that are present. But you need to do that because that is the one that determines how much product you make. And because of that, it also determines what is typically your theoretical yield, which is the amount of product you can make based on the equation in your starting amount. And in a limiting reagent problem, it is always a limiting reagent that determines how much your product you make. In a basic stoichiometry problem, we kind of assume that whatever reactant we're starting with is the limiting reagent usually, and that's why you don't have to figure it out. But you can get moles of each reactant, definitely a limiting reagent situation. And if you're not sure how to do that, keep on a lookout for the next couple of videos, and they will hopefully walk you through how to do those type of calculations. And now it's a quick one. Try to keep it very short here on this one. So I hope it helped you. If you got something out of it, let me know. If you want to learn about anything else in terms of chemistry topics, drop a comment down below. And if we have some time, we'll post it up there for you. Till next time we see you, have a good one. Thanks for watching. Bye-bye.